Yeah, thank you very much for the introduction. My name is Dominic Schulz. I'm from the Fraunhofer HHI, so Heinrich Hertz Institute in Germany. And today I'm going to talk a little bit about our, let's say QKD or quantum solutions. So especially system and components. So you can already see three of them here. So one is photonic components, one is hybrid photonic integrated circuits for quantum technologies. And the third one I'm going to talk about are our quantum communication systems. So at first, let me thank Lloyd for this very nice motivation on quantum communication and also showing a lot of those applications. I'm going to focus a little bit more on, let's say the component side here. And let me maybe answer the epic question first. So what we are offering, that you will see on the next slides. So if you see anything which is interesting for you, would be happy to discuss about that. So also we're offering, I would say, some expertise in the area of quantum key distribution. So also if you need someone to talk, let us know. And what we are looking for are always new partners. If you have any, I don't know, maybe interesting application for quantum key distribution or any technology which would be interesting, so please reach out, and maybe that would then lead to a joint project or anything like that. So as Lloyd, I'm starting with a short introduction on at first Fraunhofer. So the Fraunhofer Gesellschaft is Europe's largest research organization. We have more than 75 institutes located in Germany, but research collaborations worldwide actually, more than 30,000 employees and a budget of roughly 3 billion euros per year. So the Fraunhofer HHI is located in the capital city in Berlin. And in Berlin, so we are approximately 800 people, have a budget of roughly 120 million euros. And we are active in different research areas. So we're doing video coding, but also wireless networks. And another very stable and long-lasting research pillar is photonics. And today I'm going to focus on the photonics part and going to introduce some of our solutions and technologies. So first, let me start with our photodetectors. So for the shortwave infrared wavelength. So the application here definitely is high-speed test and measurement, and this can be used for any kind of testing, for example, 5G or any 6G system, but also for quantum communication and sensing. So technology-wise, at HHI, we have an indium phosphide foundry, so we can manufacture our own chipsets. And here, the photodiodes I'm going to talk about are indium gallium arsenide photodiodes on an indium phosphide substrate. So thereby we can cover a wavelength range from 850 to 1650 nanometers. Luckily, I can say that our performance is world record high. So we offer photodetectors up to 145 gigahertz, and also we can provide small and medium volumes, which we do in our own in-house production. So what we also do next to this chip manufacturing, also we do the packaging of those components. And the idea here really is to bring the best and optimized device performance to you as a customer. So one example for that is our indium gallium arsenide single photon avalanche photodiode. So this InGaAs SPAT, what you can see here in the middle, that is the chip we have manufactured in our premises. And on the left side, you see as the specifications graph. I'm not going into detail here. And for the rest of our knowledge, we are the only supplier of those InGaAs SPATs in Europe right now. We're doing design and fabrication. And you can see here, this is the complete module, and those modules will be available from third quarter of 2024. So if you're interested in any more specific details, I also can send you a data sheet or so. So next to the photonic components, we are also doing hybrid integration. So the idea here is to manipulate and detect the photonic qubit states from all in the visible up to the near infrared region. Therefore, we are offering two technology, or let's say integration platforms, which is one polymer and the other one is silicon nitride. And the interesting part here is that we can use those platforms. We can open the platforms up, or not the platforms, but the chips, the PICs, and then insert very high efficient optical elements like thin film filters or lenses, or even nonlinear optics. And top left, you can see, for example, one example. You can see one example here, and I'm going to explain that a little bit more in detail in a second. So as I said, we are offering multiple integration platforms, so polymer, silicon nitride, thin film lithium niobate, and we combine that with the active components in indium phosphide, gallium arsenide, and also gallium nitride. So how do we do that? So, or let's say at first, maybe one step back, the idea here definitely is like to miniaturize the components, the transmitters, the receivers for quantum communication. So I think that's a very important thing. Also, I mean, reducing cost, obviously. And what we're doing is we're etching those U grooves you can see here into our polymer chips. Thereby, we are opening up the platform, as you can see here. We are inserting two green lenses, one on the left, one on the right, and thereby we are opening up this free space area here on the chip. And now we are able to insert here optics. So for example, as I said, lenses, beam splitters, filters, or even nonlinear or non-reciprocal crystals. And one example for that is a photon pair source. We already heard about that just some minutes ago. So as you can see here, you have this hybrid PIC, this is a polymer platform, and we etched a free space section inside and inserted one of those PPKTP crystals. That is from our partner Rycol Crystals. And here we are pumping this crystal with 785 nanometers light. And the crystal then is transforming this light into, or this single photon into a photon pair. With a thin film filter at the end, we can block the pumping light. And here with this polarization beam splitter, we can then divide the two polarizations. So, and thereby create this kind of photon pair. So as you can see here from the graphs, also the attenuation or the blockage from the thin film filter is quite high, so that we really only get those two pure, this photon pair. Also, the next step is now to take this chip and also package it, that it's really easy to use in different applications. So from the components to the hybrid PICs, and now we are also talking about quantum key distribution systems, so whole systems. That is also something we do in a different department, in our photonic network department. The motivation here, the application, Lloyd mentioned that already, is this kind of long-term protection of very sensitive data, which hopefully is then also future-proof. And what we are offering here is a system which already has been deployed in the field for some proof of concept applications. You can see the system top left here. Those are 19-inch rack units. And you have a transmitter and a receiver, and it's running with the BB84 QKD protocol. And I mean, the benefit obviously is that your data is really secured by fundamental quantum physical principles here. So that will give you kind of a future-proof solution for your data transmission. Next to the QKD system, we are also offering additional devices. For example, this time-to-digital converter, we call it time tagger. That's a system to detect events and then give us timestamp for that. So, for example, the detection of a single photon here. Our competencies definitely are like in the concept development, yeah. Also maybe in the adaptation, the offering of tailor-made solutions to your application, but also system integration. So the device comes as it is, and you just have to switch it on. I would say it's quite user-friendly. And yeah, also we have an application lab for quantum communication. So if you have any idea to test something out or any else, you can reach out to us. Maybe some more information about our QKD system. So it has an automatic startup procedure and also was already tested in varying conditions. So it has a very continuous operation. It is also interoperable with a central key management system and industrial encryptors. As Lloyd mentioned, we've also tested it over free space optical links. You can see the picture down right here. To be honest, I don't know what the distance is, but looks like maybe something like 500 or maybe a kilometer or so. But you can also operate it over standard telecom fiber. And yeah, so one maybe demonstration we have already shown was that we enabled a QKD secure video conference of two German government buildings, so between two German government buildings. So that is the head of our institute here on the right, and that on the left is the Minister of Education and Science and Research, sorry. Yeah, so if you're interested in the system, so the German government is trusting us, so maybe you will also be interested in that. Yeah, so all in all, that was only mentioning some of our highlights, I would say. If you have seen anything which is for interest of you, or if you have any, let's say, very detailed question, I can definitely bring you in contact with all the experts. So as I said, we're offering those photonic components, the SPATs, but also this hybrid integration for miniaturizing quantum technologies and also our QKD system. And yeah, thank you very much for your attention.